Okay, this is June 15, C3 paper, question 7, substitution, which is really lovely. Very enjoyable when you get these right. Always, always, always start with looking at this, differentiating it, and rearranging it so that you find dx. Because you will have to get rid of dx, so you might as well do that first, and usually it will help you to get rid of something, because the whole point of doing substitution is to make the integration easier. If it gets harder, you've done something wrong, is usually where we're coming from. It should simplify to something nice. Okay, x cubed I don't want to muck about with because I haven't got an x cubed anywhere here, so I'm just going to leave that as it is. The minus 6 over there, that is my u, so that's square rooted, so I'm going to put it to the power of a half. And my dx is a thing I'm going to change straight away, equals minus 2x. So, straight away, we need to see that my minus 2 at the bottom here can be taken outside as minus a half. Integral between 1 and 2. My u at the bottom is already a u at the bottom, so that's great. X cubed, still not sure what I can do with that. However, there's an x here. So this really is the same as having x cubed times 1 over x, which surely means you cancel off and you end up with x squared, and that is what happens. So x squared is on the bottom and I've got du here. Okay, now, can I do anything about that x squared? Yes, I can. Okay, because here is an x squared, so I'm going to write this as x squared equals 6 minus u and substitute that in now. So 6 minus u over u to the half du. Oh, that's pretty good. Now, two options here. This is the one that some of you favour more often than not. So I've got 6 minus u, although you don't necessarily put the brackets around, which irritates me because then you don't multiply it outright. And bring the u to the half up to make it u to the minus a half du. Multiply this out. You end up with 6u to the minus a half minus, so u to the 1 times u to the minus half gives you, add them together, gives you that du. Okay, slightly different version. Minus a half, integral of 6 over u to the half minus u over u to the half du will give you minus a half, 6 u to the minus a half, minus u to the half du. As you can see, you end up with the same thing. Okay, now you get to actually doing the differentiation. Oops, went too far down there. Integration. Okay, so you end up with minus a half, square bracket, 6u, increase the power. So that was minus a half. So it'll go to a half, divided by a half. Okay, minus u, increase the power by a half, gives 3 over 2 over 3 over 2, divide by the increased power between 1 and 2. So this will go to minus a half, 6 divided by a half is 12, u to the half, minus 2 over 3, u to the 3 over 2. Now this 2 and 1 that I have been writing down religiously are actually x values. They're not being transferred to the u values, which you can do, which would make life probably a lot easier, and I will come back and show you. But lots of you much prefer leaving it like this and resorting back to your u, and u was 6 minus x squared. So that's what I'm going to do here, and then I'm going to come and change it, change the x values later to the 3 over 2, between 1 and 2. So now this is accurate. Okay, so let's look at this a little bit. I'm going to sub in my 2 and then sub in my 1. So I've got 12 times 6 minus 2 squared to the half minus 2 over 3, 6 minus 2 squared to the 3 over 2 minus, so I really need funny brackets here, another square bracket, 12 lots of 6 minus 1 to the half minus 2 over 3, 6 minus 1 squared to 3 over 2, square bracket, squiggly bracket, which gives me minus a half. 6 minus 2 squared, 6 minus 4, so 4, 2 square rooted, minus 2 over 3, 2 to the power 3 over 2, minus, I'll stick that funny squiggly bracket there again, 12, 5 to the half, minus 2 over 3, 5 to the 3 over 2, square bracket, squiggly bracket. Okay. Right, I'm going to get rid of this minus, I think. We'll see what happens. So, equals. Actually, I'll leave the minus a half just one more time. So, 6, I'm going to write it as root 2 because that's how the answer is given. Then I've got minus 2 over 3. Now, 3 over 2 means this is going to be 3 lots of root 2, or, which is root 2, root 2, root 2. Yep. Or I could write this as 2 root 2. So if you put that into your calculator, you will get 2 root 2 out. Then I'm going to minus 12 lots of root 5, and then that minus and a minus make this plus 2 lots of 3, and the same thing will happen here. 5 root 5. I'll square root it. Equals minus a half. Oh, where did that end? That should be 12. 12 minus 4 over 3. Need my calculator. Okay, having got my calculator, I can carry on. So you end up with 16 root 2 minus 4 over 3 root 2. Ends up giving you, I can't remember, 32 over 3 root 2, and minus 12 over, where is it? You end up with minus 26 over 3 root 5 times by minus a half gives you minus 16 over 3 root 2 plus 13 over 3 root 5. And that's the answer. Okay, what I am going to do is to go back up to where we were, just about here, okay, here, and I'm going to cover this. That's not going to work. I'll just get rid of it. Hold on. Right, so I've cleared the board and we're going to change our 2 and 1 to u's. So u was equaling 6 minus x squared. So when x equals 2, then u equals 6 minus 2 squared, 6 minus 4, which is 2. And when x equals 1, we've got u equaling 6 minus 1 squared, which is 5. So we're going to change those values to 2 and to 5. I think it should work. So, here we go. Although I would normally do it the other way around, but I'm not sure. So we'll see. A half. Then we go 12. 2 to the half minus 2 over 3 to the half, 2 to the 3 over 2 minus 2, 5 to the half, that is going to work, isn't it? Minus 2 over 3, 5 to the 3 over 2. And hopefully from that you can see that's exactly where we were, having subbed in this originally and then substituting in. You end up with the same thing. You just get there a bit quicker. But if you're not happy with doing the substitution like this, then don't worry about it. Just go straight and you'll end up with your answer here. Okay, which is perfect. Well done.